Hello friends, welcome to Eason Academy, and we are discussing about embedded system as a part of embedded system programming. This is session 9, and this session we are going to discuss about another output device, relays. It's quite widely used in the electronics systems. I'll tell you why relays and how we are going to control them and what are the use. That's why we are going to discuss today. If you notice, all these things what we are discussing are all, you have a microcontroller, doesn't matter what it is. We have discussed the microcontroller can be 8051 as volt or ARM latest. You control a pin, that's all. You can make the pin as 0 volt or 5 volt. That is what possible. So our programs are common for all the microcontrollers, not specific. The only thing varies is that the address. If you write char star out is equal to, you say 0x31. This address will vary from one microcontroller to other microcontroller. Even if you take the same ARM series, the two microcontroller will have a different address. So this address will vary from, but the code is same, the method is same. Now we have discussed about two devices. Actually, we discussed about LED and LED arranged as a 7 segment. And we have seen that the LED will draw about 10 milliampere. And it takes 2 volts. So we have put a resistor to drop the remaining 3 volts. And the current is common, 10 milliampere. So 3 volts divided by 10 milliampere is equal to 300 ohm. What is available in the market is 330 ohm. So if you change the voltage, the resistor will change. There are LEDs. For example, if you take a blue LED, there the voltage will be 4 volt. So the resistor has to be 110 ohm, not 330 ohm. Understand? If you change a resistor, the LED, then the drop voltage also changes. So the resistor also will be changing. So the voltage will become 1 volt now, because this is 5 volt. Now let us assume that I have a LED, it's a red LED. I have a red LED, which is 2 volt. And I'm using the microcontroller, which is 3.3 volt. That is, your supply VCC is 3.3 volt. Then what happens? This is 2 volt, this is 3.3. So the drop has to be 1.3. And the current is 10 milliampere. So this should be 130 ohm. So understand now. So how do you calculate the resistor here? Now we have a trick. I have a thing here. This guy is giving 5 volt. But I want to control a bulb of 230 volts, 100 watts. Think of it. 100 watts and 230 volts. What's the current? 100 watts divided by 230 volts. Roughly 0.4 ampere. 0.4 ampere. 1000 by 250 I've taken. So 4 ampere. That means that 400 milliampere. Unfortunately, the microcontroller supports only 10 milliamperes. You see here, he will give 5 volt and 10 milliampere. But what you need is 230 volts. And this is DC. And you want AC. So I want 230 volt AC 100 watts. Here, I have a DC with 5 volt and 10 milliampere. That means that 50 milliwatt. But this, so This microcontroller can control only 50 millivolt, whereas my bulb is 100 watts or 230 volts. Doesn't match. So what we do here is we make a device. Okay, this device you connect the bulb. And this guy will control. This device is what we call relay. Let us discuss about relay now. Let us discuss about relay. Now, what is a relay? Nothing but a small magnetic coil, and there's a small spring. There'll be a connector. It's a small piece, metal piece, iron piece, and there'll be a stoppers. So this is the input called X and Y. This is two input. This is a control input. Control input. This is a main supply. This device, this is spring. So what happened when you give 0 volt here? No magnet. Because there is no magnet, this guy will be the top. There will not be any contact. The moment we apply 5 volt here, what happens? This guy get magnetized. So this guy get pulled and it come down and stops here. When it stops, since it's a metal piece, it is making the connection to these people. Now, if you give here 230 volts, if you connect a bulb here, 100 watts, understand? Now, this guy is controlling. So your bulb 200 watts at 230 volts is going to glow. So how do we make the relay representation is very simple. We have an input and output, X and Y, and we have a control input. So the control input will control that. So I remove this. I remove this now. So what we do here is we have a same methodology. What we did LED, we have a microcontroller, which is the out pin, bit 0. Now here we connect a relay. This goes as a coil. Okay, now we have, it controls the two inputs as we already discussed. This is the input and output. And here you connect a bulb, 230 volt supply. Let us assume this is a switch. Now this coil control the switch. So you can easily connect now any device, any AC to everything can be connected. But the only thing is you should know that how much is this guy can take the current. That's all. Ultimately, every device you should know about rating. How much, what is the voltage? What is the current? In your house, you have wires. People say that wire, okay, can withstand only 5 amperes. Now, if you give more than 5 ampere, the wire will burn. That means what exactly they are trying to say is this. You supply a voltage of 230 volts, you have wire of 5 ampere, you connect a heater. of 2300 watts. Now see here now, you're given 230 volts supply. Now this is how much? 2300 watts. But the wire what you are used is can take only withstand 5 amperes. Now this is 230 watts divided by 230. The current is 10 amperes. So because of the 10 ampere, this wire will burn. That's why you know that there are houses or offices, companies everywhere. Sometime the factories, you will hear that there's a fire accident. Okay, that sometime like it happens like this. That means that the wire. So please understand, the thing is very important. This is called rating. If the microcontroller pin output, they say 5 volt and 10 milliamperes. That means that if you try to draw more than 10 milliampere, this device will burn. The device will burn. Understand now? That's why we call the thing as a rating. In your house also, you have a plug point, small one, say 5 amperes. Then they will say a big plug point. They will say 15 amperes. Then there'll be a different plug point for ACs. They will say 25 amperes, like that. So based on the current you have to use. So in the embedded system, there are two portions. In the embedded system, there are two portions. One portion is quite simple. That is called embedded programming. That's the simplest. You have a microcontroller, you take the input, you give the output. And you get 0 volt or 5 volt, you give 0 volt or 5 volt. Nothing will happen. But you write a program here. This is what you are supposed to master. There's a huge demand for this. Now the thing is that by making this pin as a 5 volt or 0 volt, what I'm going to do? I'm going to control a LED. Then things are very easy. Suppose now you should know that what is the pin. For example, I will show you a small thing. I'll show you a data sheet, then you will understand. The moment you see the data sheet, you will understand that is the information you should know. Okay, now let us see a data sheet. Then you will have a good idea. One minute, I'll open the data sheet. Now and then you know the data sheet, then you will know that what is the comparison, what exactly the reality. Now let's go to the same chip what we are using, 2560. If you open any data sheet, any company's data sheet, you will find out some information. That's a very critical. See here, if you come down, there's a chapter called electrical characteristics. See here, 31 here, electrical characteristics. Okay, now come down here, the electrical characteristics. They will say that what is the maximum current? What is the maximum current? And what is the, here you see here, the temperature. Okay. See, DC current per IO pin is how many thing here? 40 milliampere. Okay, I said 10. Then maximum operating voltage is 6 volt. We are using 5 volt. Am I right? See here, you check here, VOL. What is that? VOL. That is output low voltage current. Say VOH. That is output high voltage current. The output can be low voltage or high voltage. That we have already discussed. I'll show you the thing. The last class I told about this. If you remember, sinking and sourcing. So from the pin, if the current can go out, that will happen. That will happen when the pin is 5 volt, the current will go out. Okay, that's why we call this a V, output high. I, output high, IOH. That means that VOH, voltage on output, when the pin is high, what is the voltage? And they say here, see here, VOH. I hope you see that. Otherwise, I can make it, I can zoom it. See here, VOH, output high voltage. That time, when it is 4.2 volts, what is the current? 20 milliamperes. 20 milliampere. Same way, here you see, V output low, it is 20 milliampere. Somewhere they see is a minus sign. That means that when the microcontroller is giving out, we call minus. When it is coming in, we call plus. That's why they have it like this. See here, IOL. Input low current when the output is low, 20 milliampere. Now, what is each pin? We'll see that. Each pin, what is the, will be the next page. This is a total supply current. This is total supply current. You see here, each pin here, IOL is 20 milliampere. That means that the data sheet says that you cannot get more than 20 milliampere at 5 volt. At 3.3 volts, you get maximum of how much? 10 milliampere. Let us assume 5 volt. Since we are discussing about 5 volt, you get 20 milliampere. Okay. So do you understand? I've showed you the data sheet. So that's why I wanted to show you from the data sheet point of view, what is the current. This 20 milliampere minus 20 milliampere. Okay. When the current is going out of the microcontroller, they call negative. When coming in, they call positive. Okay. Now you see here. So this is called IOL. This is called IOH. You have to remember only this. VOH. O means output. L means when it is low. What is the voltage? It will be 0.9 or 0.6. That's the thing. This is called IIL, IIH. Input current or the IOP is how much? 1 microampere. See that? Input current is nothing literally because it's all CMOS devices. So this is what the only information they given. Now let us worry about 5 volt. Now the problem is this chip, microcontroller chip is giving you only 5 milliampere. 5 volt at 20 milliampere. So please understand, this guy is giving 5 volt and 20 milliampere, not more than that. This is a very small information, but normally we don't understand this properly. 5 volt and 20 milliampere. But Your bulb requires 100 watts. This is 5 into 20 is 100 milliwatts. See here. So this controller can give only 100 milliwatts, but you need 100 watts, almost 1,000 times. The easiest device, what people use is the relay. You have an input to the coil and control, and here there'll be two inputs. But they don't give any voltage. You need to connect it. You need to connect them like this. You need to connect like this. Take a supply, connect the bulb, connect to neutral, phase and neutral. Now you see that connection now? Now you write a small program. Char star out. Out is equal to 0x01. Let's say bit 0. Now this become 5 volt. When this become 5 volt, the motor will on. The relays are costing only about 5 rupees. 5 rupees or 10 rupees. That's all. They're only very small. They cost you only 5 to 10 rupees. Nothing, not more than that. So understand this fact. Okay. If you have any doubt, you can ask me now. If you have any doubt, I'll explain you more. There's some issue with the relay. But before that, I wanted to make sure that you understand this. That is why we use relay and how it is used. Simple. Same. Instead of LED, I'm going to connect a relay. That's all. But the thing is here, you can connect LED, whether you can connect at your house. This is a small method. You can buy your ordinary small board, microcontroller board. You can control any device. You can control, let's say, another pin. Another pin I can control a relay. Sorry, a relay and a AC. Fridge, anything can be controlled. Understand? You control any device using this. This is a very, very cheap method. See that? It costs you only 5 rupees or 10 rupees. That's all. In a very cheap method, you can be able to control a big devices. And there's one more advantage here. There is isolation. I'll draw it here a relay. If you take a relay, I have a coil. I have a coil. And I have a connection here separately. There is no connection between these two. That means that your microcontroller is operating at DC. Your bulb is operating at AC. So there is no connection between your control input and the main supply. Am I right? So if you have any doubt, you can ask me now. I'll tell you what are the small problems are there in this. Before I tell you the problems. So that's good. Now you don't have any doubt. But there's a small problem. The problem is this loads are inductive load. And what we are using is as a switch. When you do on and off the switch, what will happen? See here. There are two electrical components. One is called capacitor. One is called inductor. The inductor current does not change. immediately. Understand now? The current does not change immediately. It will change slowly. It will change very slowly. The capacitor, the voltage will not change immediately. Voltage. So capacitor, once you charge, then that guy will discharge slowly. That guy will, he will take some time to discharge. Take some time. That depends on the resistor you have it and load. That's all. Depends on the current. So capacitor does not change immediately, whereas the inductor does not change immediately. Because of that, I have a transistor here. I have a transistor. I make the switch off. When I make the switch off here, it gives you high resistance. But the current through the inductor does not change. So the inductor goes like this. Your transistor is not a switch. It is a high resistance, or because of that, there will be a heavy voltage will get induced. We call that as a back EMF. Electromagnetic force. That's called back EMF. Because of that, the device will get damaged. The device will get damaged. So what people do here is, to avoid this device, they have a diode here. Normally, when you apply here 5 volts, the diode is reverse bias. Since diode is reverse bias, the current will go like this. The relay will be operating. The moment you make it to 0 volt, that time the current here will pass through this diode. That's why they call this as a freewheel diode. It makes a current to freely pass through at the end. So this is a must on every, whenever you connect an inductive load, we call this relay, coil, everything as a inductive load. So when you take an inductive load, you should connect this across this, not the other way. The other way, if you connect with a short, if you connect like this, then the entire current will flow through this because it's forward bias. So relay will not be working. So you have to connect like this. So when you apply normally 5 volt, nothing will happen. Everything will be okay. The relay will be working. The moment you make 0 volt, momentarily, the current in the relay will go through this. Okay. So this is a very, very important in your circuits. Whenever you use an inductive load, you will see always here. Any inductive load, you will see that. And sometimes people are actually worried. Sometimes people worried. The problem is, even though you have a inductor and the freewheel, everything, there could be a possibility that this will get damaged. Which one? Your microcontroller. How do you avoid it? What that they do some small component here that is called, study this. This is called optocoupler. Nothing. The name itself is a coupler. It's a connection, but instead of wire, you make it optically isolated. That's opto isolation. It's an isolator. So if you give a voltage here, this side, there'll be a diode, photodiode. Now, there'll be a voltage here, separate. Now, The moment your light passes through this, then it will conduct. Otherwise, it will not conduct. So this gain is based on the light. Because of that, there is no connection, the input and output. This circuit is saved. So we have two things to precaution. One is freewheel diode. The other one is optocoupler. So these are all called, I told you now, these are all called, here is a small trick. I have a word. We have called this as a embedded. This is a process. But when you connect this relay and a bulb and you supply here 230 volts, it goes like this. This is called, you connect a diode here for the freewheeling. This is called embedded system. So embedded program can, so this is called embedded programming. This is called embedded system programming. Both are same. The only difference is here you are controlling the pin. But when you do embedded system, you are responsible for the full. You should know about all these things. You should know about how the relay works. How do I control it? All the information has to be known to you. So you understand the difference. That's why what I do here is stop here. Don't get confused. Don't get confused all these things. They're all very easy. What you should do here is you should master LED or 7 segment. And fortunately, nowadays in your simulation, I'll go to the simulation. We go to the simulation and show you that. Now you connect here. You'll be able to connect anything here. As we discussed already, LED, everything. You also have a relays. See, you have a relay. NC means no output. So this is a coil. You give an input and P1, P2, and this output. So one I'll show you a small thing here, but it's not may not be useful to you big. Since it's available, since he has mentioned this, I'm mentioning this is called DPDT. Okay, I'll explain to you right now what is a small thing. Not a big one, but what I'm trying to say is that you also have a relay here in the simulation. You can test it here. Okay, let's go back to the board. So there are some this may not be very useful to you, but I'm just giving you that. I have an input, I have an output, I have a switch. Okay, I have a single input, single output. And I will do either on or off. That's all. This is called SPDT, SPST, single pole single throw. The other one is SPDT. That is nothing but I'll have two inputs. Both will be controlled. DP ST single throw. I do one off single throw, but there'll be do a double pole. It's called DPST. You may ask, what is the SPDT? Now I'll tell you now. I have an input. I have an output. But I have a two output. This guy will control here or here. It's called SP single pole DT. Dual throw. I can throw here or here. I can connect it here or I can connect it here. You may be knowing that in the electrical wiring we have called staircase wiring and all. Like normally you know that when you have a this most of you know that. If you don't know, please learn it. It's very nice. You can write a program for this. I have a switch here. I am coming out. From out, I'm coming to the house. And there's a bulb here. And there'll be a switch here. So what I do here is, when a person comes here, control the switch, then the bulb will on. He will go up, put the bulb. Now I make a small connection here. See that. I have a 230 volts. This is switch 1. This is bulb. This is switch 2. See here, this is bulb. Now, let's say both are like this. Up. Both the switches are up. Now what happens? When you are coming from outside, you will change the position to down, up to down. Then I make it down. Now what happened? The current is flowing through this. So bulb is glowing. But when the person reaches to the top, I make this guy down once again. This guy, S2, down. Now what happened? There's no current flow. Now the bulb is going to be off. Understand? You can actually write a small program here in your embedded system. You can make a small product. There will be two switches. There will be a bulb. When I enter, I'll press the switch. This is your microcontroller. You write a program here. This will become a product. This is the way the products are designed. You can give it to a EB guy. You connect two switches and connect a bulb. That's it. This become your product. You will have a software here. Embedded software, which will control that. So understand what is called SPDT or DPST. Don't. I just want to introduce you these two terminologies. So now I'll give you a small idea. See that. We have a relay here. I have a relay here. I have a relay here. I have 4 relays. Understand one thing. I have 4 relays. I have a microcontroller. Understand? I have a microcontroller. Then I have a resistor here. And this I connected a 230 volts. This I connected to neutral. And this is phase. Now this wire I connected to this resistor. This is R. this is controlling this guy and this guy. And this one is controlling the another pin. This. Understand now? This is bit 0, bit 1. Bit 0 controls relay 1, 2, 3, 4. Relay 1 and 4. Bit 1 controls relay 1 and 3. Now I make this as a 1, this as 0. What happens? When this is 1, this is on. And this is 1, this is on. Now what happened? The current is flowing through this. So the current is flowing via resistor like this. Now, instead of this, I make this one as 0 and this one as a 1. So this will be on, this will be off. And this will be off, this will be on. Now, the current will flow through this, like this way. So I'm changing the direction of current. See, normally like this, think a minute. I have a resistor. If I connect a battery like this, I'll draw here. So I have a battery. I have a resistor. Now, the current will flow like this. Now, if I want the current to flow other direction, then I have to change the battery. Without changing the battery physically, it is not possible. I cannot change the direction of current. But here, by using your software, you say that CHAR star out. Out is equal to 0x31. That's the address. Now star out is equal to 1. That means this will be on. The current is flowing through this. When you make it star out, it's equal to 2. 2 means 1, 0. That time, the current will be flowing like this. Anybody can tell me what is this circuit? Anybody can tell me this circuit? Any hint? Anybody please tell me what is the name of the circuit? What is the name of the circuit? Anybody please? I'll give about a minute. Anybody knows this? It's a very, very famous circuit that I've given you the idea clue. Very, very famous circuit. Anyone, please? You'll be using this in future. Please. This is called very famous H bridge. This is like a H shape. That's why I call this a H bridge. With the help of the H bridge, I can control the flow of current any direction without physically changing the device. The device can be as such. Next session, I'll tell you the usage of this H bridge. Then you will be surprised. Next session, we'll discuss about the usage of this. That time you will know that. Okay. So this is the place where we use important component relays. Next session, we will discuss about how to connect motor. There are so many methods are there. There are so many motors are there. We will take one motor and explain to you the next session. Then I'll explain to you coming days various motors. You know that motors called DC motor, AC motor, stepper motor, servo motor. There are so many motors. Okay, brushless motors, everything. We will discuss on the next coming days. The coming session we will discuss about one motor, a DC motor. So please understand. Watch these videos. There'll be these things will be the very preliminary one. You don't have to know anything. You just write a 4-line program. You can control anything as you wish. This will be when you start doing it, they'll be very interesting. Okay, so please start writing programming. You know that these videos are going to be with you always in the drive. You can watch anytime, but the only thing required to understand these things is practice. You may think that why Balaji is telling repeatedly practice, but there is no other way. Please. Then you will understand these things faster. So let the table be there as such. You just try to understand the HPH functionality. That means that when bit 0 is on, bit 1 is on, bit 0 is on, bit 1 is off. Bit 1 is on, bit 0 is off. What will happen? When both are off, both are 0, 0, what will happen? When both are 1, 1, what will happen? Okay, think of it. We'll come back after the break.